Hi Zach! I know you've already finished Calculus 1, but I'm bored and it's still kind of fun making these videos. So we're going to start where we left off in October. My last video was about continuity and discontinuity. So next, we should talk about some theorems about continuity. There are two main things we know when a graph is continuous on an interval, and they can be summed up with the intermediate value theorem and the extreme value theorem. The intermediate value theorem, or IVT, says that if f is continuous on an interval, such as a, b, then f takes on every value between f of a and f of b. This means, for example, that if f of a, that is the value of the function f of x at x equals a, is 6, and if f of b is 4, then since f of x is continuous, at some point between a and b, there must be some value c such that f of c is 5, because 5 is between 6 and 4. We don't know exactly where the value of c is, but we know it exists on this function. Take this quartic function, for example. We don't want to have to factor that to know if a solution's on the interval, but since it's a polynomial, we know it's continuous. A solution, we know from algebra, is found when the function is equal to 0, so let's see if 0 is in between the values of f of -1 and f of 1. When we plug in -1, we get -9 halves, and when we plug in 1, we get 33 halves. 0 will fall between any positive and negative number, so there's at least one root on the interval -1 to 1 for this quartic function. The extreme value theorem says that if f of x is continuous on an interval, such as a, b, then there is some value c such that f of c is less than or equal to f of x for every value of x on ab, and some value d such that f of d is greater than or equal to f of x. This means that if a function is continuous, there is a local maximum and minimum on an interval ab. But keep in mind that the values of f of c and f of d can be less than or equal to and greater than or equal to, so there could be more than one maximum or minimum with the same value. In the case of a constant function, every value is both a maximum and a minimum. And finally, let's get to the example. I'll make another video explaining how to do this, as I've done in the past. For this problem, you're going to find whether or not the function is continuous on the given intervals. Then, using the knowledge of whether or not it is continuous, you should be able to find whether there are solutions on the interval and where the maximum and minimum values are. Good luck! I'll see you in the next video. Bye!